Pew pew pew! Pew 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 pew! Pew pew pew! Oh wow, it's so pretty! Wow, look at this! Oh yeah! Today we're going to add different spell in the game because right now we only have one. It is the test spell and it is only spawning some red cubes in the scene. That's not that pretty. So today we're gonna add a bunch of different ones so it's a bit different. It's going to be nicer and also we'll be able to test a multiple configuration at the same time. But as I already said in previous videos, I'm not really good with particle system and I don't want to waste my time to try to explain you that. So instead, we're just going to do simple blueprint animations the same way we did for the red cubes. And I think we can really achieve something that is pretty interesting without VFX. So let's get to it. So in Unreal, before creating our spells, there's just one little thing that I want to change. Because if you remember in the previous video, let's say I'm going to go back in the BP combat system right here. We can see that when we are spawning the spell, so in cast spell, at the end we are spawning the actor, and we rename the variable right here to be attacked indexes instead of target indexes, because these are the indexes that we are attacking, not the ones that we are targeting. And in the spell animation, it's still named target indexes. So I'm just going to rename the variable inside the animation actor so it matches. And I'm also going to re-add the target index because it's going to be helpful depending on the spell. So to do that, I'm just gonna go back in my spell animation. So here in spells and open a BP spell animation right here. And on the left, I'm gonna start by renaming my variable. So target indexes, I'm going to rename it attacked indexes. And then I'm just going to duplicate the origin index to rename it target index because some spell will need that variable also. So now we can compile the spell animation and go back in the combat system just to refresh the spawn actor node to have access to the new variable. So refresh node right here. And now we can reconnect the attacked indexes to the attacked indexes. And then we can go get the target index that we have right here. We can paste it there and connect it like so. So now all the spells are going to have all the informations they need. Perfect. We can now compile and save both those blueprints and close them. And now to start creating our spells, we're going to need a few new assets that we're going to use to make the spells a little bit prettier than just some red cubes on the grid. So to do that, I'm going to need to import those, which I'm going to do inside a new folder, but I'm going to organize a few things at the same time. So here in my spell, I'm going to start by creating a new folder, which I'm going to name spell animations. And I will take the time just to move the components inside the spell animations because that's where I think it makes more sense. So move there. And then inside my spell animation folder, I can open it and create myself a new folder that I'm going to name assets. And then inside the assets folder, I'm going to import my assets. So here I have a few assets. I have all my static meshes right here that we can import. Now in Unreal, we don't want to generate any collisions because we don't need those. And then we don't want to create the materials either. But other than that, everything else should not matter too much. So now we can import all on the meshes. We can close the error. We don't need to worry about that. And then we have to import the texture. So I have my texture. I can drop it in Unreal. And here we go. It's imported. So now we can save all. And we can now go back inside the spell here to create our first spell. And it's now time to create our first new spell. And every time we want to create a new spell, there's 3 steps to do right now. So the first step is to create the animation we're going to use for that spell. The second step is to add the new spell name inside the enum for our spells. And the third step is to add that spell information, like all the data, inside the data table. So we can find it later on in the game. So let's do that. The first step is to create the spell animation. So I'm going to right click on BP spell animation and create myself a new child blueprint class right here, which I'm going to name BP underscore spell anim underscore melee hit. And then I will move that animation inside the spell animation folder that we just created. So here we go. We now have the spell animation created. And now we need to do the data table and the enum. So I'm going to go in my utilities folder and open eSpell. I will create myself a new row, which I'm going to name melee hit because it is the name of the spell we just created. And now what we're going to do is go in the data table, create ourselves a new row, which I'm going to keep the same name. So the same exact name, so melee hit. And I will select the melee hit enum value right here. So now they are both assigned together. And then inside the assets, we have to select the animation we want to use. So we're going to obviously use the new animation we created, so melee hit. And then for the cast, the range pattern, we want to use, let's say, a diamond, which is the basic shape that we have, the most basic one. And then for the range, minimum and maximum, it's going to be 1 and 1. So just one tile in front of you, I think it's good enough. We don't need the line of sight because we don't need it. And then the AoE, we don't need that either because it's just a punch or a melee hit. So we don't need any special things with that spell. So now we can just save the data table and go do the animation itself. So I'm gonna go in my animation, here in my spell animation, and open BP spell anim melee hit that we just created. And here to create the animations for our spells, what we need to do is just to override the play spell animation function that was in the parent class. So right here in my function, I can override one of those functions, and the one we're gonna do is the play spell animation function right here. So we're gonna override that. So we're not gonna do what the parent was doing, so which is spawning all the red cubes and things like that. We're just going to override that and do this animation, the specific animation we want for this specific spell. And then once we are done playing the animation, we just want to make sure that we don't forget to call the complete spell animation event that is inside the parent class also. This function in the parent is responsible to destroy the blueprint. So if we don't want to have a bunch of spell blueprint laying around in the world, we have to make sure to call this event once we are done playing the spell. And actually, for the melee hit, I'm going to be super lazy. I'm just going to put a delay between the beginning and the end, just like that. Because we're not gonna really spawn anything for the melee hit. It's going to be linked to the animation for the unit, the specific unit. So if the unit has a hammer, it's going to play the animation for the unit that attacks with that specific hammer or something like that. So all the units are going to have different animation for that specific spell. So we're not gonna add anything extra in that spell. We're not gonna splash any cubes or play any VFX, sound, or things like that. You can add them if you want to, but in my case, I'm just going to use the animation that is already inside the unit. So we're gonna do that in the next few videos. I don't know which one, but we're gonna link that spell to an animation, and that animation is going to be played already. So it's going to be good enough for just a basic animation, a basic attack animation from one unit to the other. It's going to be super simple, and it's going to work good enough in my opinion. But as I said, if you want to add more stuff, you can do it. That's not a problem. But for now, I'm just going to compile, save this animation, and we're done with it. So we can go do the next one. And now for the next one, we have to do the same exact 3 steps. First, we create the spell animation. So I'm gonna duplicate my spell anim melee hit because it doesn't have anything in it, so we can use it as template. And I will rename it spell anim underscore sword slash. That one's gonna be more interesting. Then the second step is to add the spell inside the enum. So I'm gonna go in my enum, add a new row for the new spell, which is the sword slash. We can save the enum. Then we can go in the data table, add a new row for the new spell, rename the row sword slash, change the enum value so it is sword slash also. Select the animation class, so we have the sword slash spell anim we just created. And then we have to set the range. So in this case, I'm just going to also keep a diamond, and I'm going to make it 1 and 1 for the range also. No splash damage yet. We're gonna do that later. But for now, no splash, no anything, just a simple cast 1-1 diamond shade. Now we can save it, save everything, and go open BP spell anim sword slash to do the animation. And since we want to add visual to this animation, I'm gonna go in the viewport and add myself a new static mesh component. For the static mesh, we're gonna select the sword mesh that we imported at the beginning, so SM sword, and then we're gonna set some material, so you can select which colors you want to use for your sword right here. And this is what I decided for my colors, so it's a mix of gray and red. Now what I'm gonna do is just reorient the sword a little bit, just so it faces the right axis, which is the x-axis, the forward axis in Unreal. So I'm just going to rotate it minus 90 degrees, just so it's aligned with the red line on the grid, like that. And I'm just going to move it upward just a little bit. So let's say 100 unit in the air, something like that. I think it makes more sense. It's going to be better. It's going to look nicer when the sword is going to come from the sky and go down on the opponent. Okay, good. So I guess that's done for the visual. Now we're just going to need another component for the animation of our sword. We can animate the blueprint itself. We can move the actor around if we want to, but I think it will be better to just move a component in the hierarchy instead of the whole actor. So what I'm gonna do is select my root right here and add myself a new scene component, just like that. So it adds it right in the middle of the blueprint actor, which is exactly what we want. We want the scene component to be in the middle. And then we can take the static mesh and add it as a child of that scene component. So now when we are animating the scene component, it's going to also move the sword. And then I'm going to rename the component anim underscore rotation and scale. So we know that both the rotation and the scale of that component are animated in the blueprint. And then what we want to do, because right now we have a component and we want to animate it so it looks nice. And I think we are going to start simple with this blueprint, and the only thing I want to do is animate that rotation just to swing forward and hit the enemy that is in front of us. So, shoo, shoo, something like that. It's super simple. It's not going to be complicated. It's the first spell we're doing, so we're keeping it simple. So, okay, good. Let's go do that in the event graph. And here, first step we're going to do is first start by deleting the delay, because that was just for the melee hit. We don't need it right here. And I'm just going to move that out of the way. And then the first step we want to do for that spell animation, well, it is to just spawn the actor and place it on the right tile, because right now it just spawns somewhere in the world. It doesn't really know where it is. So what we're going to do is just move the actor somewhere on the grid where the spell starts, where is the origin of the spell. And then we're going to make sure that it faces the target. That way, let's say the target is in diagonal, it's just going to look diagonally and face the target. And the way we're going to do that is just by doing a set actor location and rotation using the origin index for the tile transform. So we're placing it on the origin index. And then we're gonna look at, so find the look at rotation, the target index. So if the spell is in diagonal, the target is in diagonal, we're gonna rotate the spell, look at the target, and then we're gonna face the target and shoot the spell in that direction. And then to animate the sword, we're going to use a timeline, the same exact way we did when we were animating the animated shape for the default spell. So we are going to play the timeline, and once the timeline is finished, well, we can simply call the event complete spell animation, because the animation is going to be over. And now in the update pin of our timelines, we want to update the rotation and the scale of our anim rotation scale component right here. So to do that, it's simple. We just have to do a set relative rotation to animate the rotation, and then we have to do a set relative scale 3D to animate the scale of the component. And we're going to start with the rotation, and there's actually just one axis we want to rotate, and it is, I think, the y-axis. If I go here in my viewport, we can see that the rotation that we want is happening on the y-axis. So that's the axis we want to rotate. So what I'm going to do is go back in my event graph, split my rotation, and then we just want to connect the pitch to the timeline. So I'm just going to go in my timeline and create myself a new float track for the pitch. I named the track rotation Y, and I've also changed the length of my timeline to 0.5 seconds, otherwise it will be way too long to have a 5 seconds animation. Now what I'm gonna do is add 2 keyframes to my curve, just like that. And then for the values, what do we want? Well, first, we know that the first key starts at the beginning, so at the time 0, and the second key ends at the end, so 0.5. So that's easy. Then for the rotation values, what do we want? In the viewport right here, we're gonna start, let's say, at 0. I guess it makes sense. And we want to end up at, let's say, minus 70, minus 90, minus 80. Minus 80 would be good. So let's do that. Start at 0, end up at minus 80. So let's do that in the timeline. So the first key is going to be 0 and 0, and the second key is going to be 0.5 minus 80. There we go. Now we can click on the 2 little arrows here on the top left corner to recenter the curve, just like that. And I don't want it to be like linear like that. It's not pretty. So what I'm going to do is just change it to auto, and then I can tweak the curve a little bit just so it makes a little bit more sense and it's a little bit smoother, just like that. So now the sword is going to go backward a little bit and then slash forward. And I think it makes a really nice animation. Now we can go back in the event graph to connect it. So right here, I can take my rotation Y and connect it to the pitch, just like that. And now for the scale, what do we want? Well, if I go back in the viewport, I think that it would be nice to have the animation of my sword going big, 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 and then scaling back down once the animation is completed, just so it's going to look way more impressive, because the sword is going to be super big and then poof, crush on the head of the enemy. So let's go do that. I'm gonna go in my timeline and add myself a new float curve. I'm just going to name it scale and add myself 3 keys in the timeline. So 1, 2, 3. The first key is going to be at the beginning of the timeline, so 0, and it's going to have the default scale, so 1. The default scale is 1, so the sword is going to be the normal scale at the beginning. And at the end of the timeline, I'm just going to make it 0.5, so it's at the end, and the scale is going to be, let's say, 2, so double the size at the end of the animation. I think it makes sense. We can make it a little bit smaller, maybe, if it makes more sense. We'll see. But for now, that's good enough. And for the key that is in the middle, what is the maximum size we should have for the sword? I think 5 times the size of the sword is a good value. I'm not sure. Let's say 5, and we can change it in the future if we want to. Now I'm just going to tweak the curves a little bit, just so it looks a little bit better. So I think something like, I don't know, something like that maybe. That's not too bad. And then at the end, we want it to go down like that. We don't want it to slow down while it's going down. So something like that. I think it's not too bad. We can move the key a little bit forward if we want to. Anyway, you can tweak the curve as you wish. Now I'm gonna go back in the event graph and connect my scale to the new scale 3D, just like that. It's going to convert it to a vector 3 for us. And now we should have the animation of the sword completed. We can compile and go test it in the game. We were not testing the previous animation because it was nothing, but this one is a little bit more interesting. So let's see how it looks. So now in my spells, I should be able to select the sword slash. And now if I select a tile on the grid and try to cast the spell, we can see that it now plays the sword slash animation. Choo, 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 choo. So I think it's not too bad. We can tweak the curve to make it a little bit better, but I don't really care. I think it's good enough. There's just one little thing maybe I want to change. Maybe it's a little bit too straight because, yeah, if we are facing it completely, we can see that it's pretty straight. So let's add it a little bit of rotation just so it looks a little bit nicer. So let's do that real quick before going to the next animation. And to do that, we're gonna go in the viewport, select the root, add a new scene component in the middle. And this time I'm just going to move the anim rotation scale under the scene component. And what I'm gonna do with the scene component is actually just rotate it a little bit. So let's say in the x-axis this time. So let's do something like that. So give it a little bit of default orientation. So when it hits the ground, it's going to look a little bit like that instead of a straight line. So I think it's going to help. Now I'm going to compile and go see how it looks in game. And there we go. I think it looks way better now because it has a little bit more curve. It's not in a straight line. So that looks more interesting and it doesn't break the other directions either. So I think that's pretty interesting and that's good enough for this spell for now. We can always come back and polish it in the future if we want to. But for now, that's good enough. For this one, we have still a bunch left, so let's go do them. And actually, for the next few animations, we're gonna go way faster because the logic is pretty much the same. We just have to move some objects around, so let's not waste too much time on that. So follow the same 3 steps. We create the blueprint animation. So first, duplicate the spell anim melee hit. Why not? We can rename it Sword Throw because that's the name of the spell. Then we can go in the enum, add the new row, which I'm gonna name Sword Throw. We can save it. Go in the spell data, add the row for the Sword Throw spell. We can change the enum value to be Sword Throw also. The animation, we can select the Sword Throw we just created. For the range pattern, this one I'm gonna make it a line only. And I will make it a 3-3, I think, for the animation. Or maybe, actually, no, 3-4. I think that's good enough for the range. Okay, now we can save it. And actually, for that one, I want to enable the line of sight. So why not? Line of sight, enable. Okay, that's done. Now we can go do the animation itself. So I'm gonna open the new animation we created. And the next steps are the components. So I'm gonna go in my viewport and add myself the 2 new components I'm gonna need. So I have a scene component right here to animate the location, rotation, and the scale of my sword, which I'm still keeping the same sword right here. I still have the same mesh, the same materials, it's the same sword. I just placed it a little bit differently in the scene. So it's a little bit in the air, so 100 unit in the air, same thing as the previous one. And then I've rotated it 90 degrees in the y-axis, just so it's flat with the ground. So good, we now have our components. We can go do the logic in the graph. And we're gonna start this fill animation the same exact way we did for the previous one. So we start by removing the node we don't need anymore. Then we can set the actor location and rotation on the grid using the origin and target index. And then we play a timeline. And finally, we can call the complete spell animation event. And then what do we want for our animation? Well, the unit is throwing a sword. So we want the sword to start from the origin tile and go all the way to the target tile. So let's do that. I'm going to start by getting the origin index tile location, the target index tile location, and then we can lerp in between them. So we're going to lerp from the origin to the target. So we're throwing a sword from the origin all the way to the target. Then we're going to use that to set the actor location. So now we just have to set the alpha in the lerp, which we're going to do inside the timeline. So let's open it. And this is what I did. So first I created myself a new float track, which I named the actor location alpha. And I've also made sure to change the length of my timeline. So now it's 0.75 seconds. I've added myself 3 keys in the timeline, and it is an alpha. So we are starting at 0, which is the origin index, and we're going all the way to the target index in the middle of my timeline. So 0.35 in the time, I guess, and the value is 1. So starting at the beginning, throwing the sword, and it's going to reach the target at 0.35 in the timeline. And then at the end of the curve, we want the sword to come back to the origin, because I like the idea of throwing a sword that comes back, like a boomerang or something like that. So we are throwing the sword, it's going to reach the target right here, and then it's coming back to the beginning right there at the end. So now we can go attach it to the alpha in the graph. So actor location alpha inside the alpha of the lerp, and we can go actually try that in game to see first how it looks before making any other changes to it. So let's go do that. So this is how it looks. Okay, it's not that pretty now, right now, like but we have the basics, like the sword is moving, it's attacking the desired target, so the target we really want to attack, so that one, this one, that one, so it works. But now it's just time to make it more interesting. Maybe let's make it spin and maybe go bigger in size and then smaller and things like that. So we have a few changes that we'd like to make, so let's go do them, and it's going to look way nicer afterwards. And actually get ready, because it's going to be really packed really soon. So right now I created myself 3 new float track in the timeline, because we're gonna animate 3 new curves, and we can open the timeline to see how they look. I didn't add any keys to them right now, just created them and renamed them. So I have my location Y, my rotation Z, and also my scale. And these are my 3 float tracks. And now we can just start by connecting them, and then we're gonna add the keys together. So I'm gonna go in my event graph to connect them. The first thing I'm gonna create is a set relative transform on the anim location rotation scale component that we created, because that's why we created it. We want to animate it, so let's do it. And then for the transform, I'm just moving it right here. I'm doing a make transform just because it's going to be packed, and I think it's cleaner if I move it right here. Then for the location, it's simple. We take the location Y from the timeline, connect it to the vector, and that's it. Finally, we have the rotation, same thing. We take the rotation Z, connect it to the rotation Z, and it makes a rotator. And the last thing, we have the scale that we can simply convert from a float to a vector to apply it to the 3 axes at the same time. Okay, yeah, that's packed. But anyway, it looks nice, so whatever, I guess that's good enough. Anyway, now it's time to go apply the values in the timeline, so let's open the timeline to do the curves. And here they are. So for the location Y, the idea was that I wanted to throw my sword like in an arc, kind of. So I'm throwing my sword, let's say on the left or on the right, whatever, and then it goes in an arc, hit the target in the front of me, and then comes back on the other side, and then comes all the way back to me. So let's say like the same way as we are throwing a boomerang. We are throwing it on one side, and then it's coming back on the other side. So that's what the idea was. So here at the beginning, we are starting at 0, 0, which is in the middle, is where I am, so that's good. Then right here in the quarter of the path, we are at 200 unit on the right of the unit, so we are throwing the sword on the right. Then it's coming back to the middle to hit the target, and then finally it's going to the left. So going to 200 units on the right, hit the target in the middle, going 2 units on the left, and then coming back to the origin, which is 0 right here. Then we have the rotation Z, which the idea is just to make the sword spin on itself super fast while hitting the target and doing the path and everything. So it's super simple. We are starting at 0, 0, and then by the end right here at 0.75, we are getting a value of 720 degrees. So the sword is going to spin super fast on itself, let's say 5 times, 6 times, something like that. And finally, we have the scale right here, which is super simple. We start with a smaller sword, so let's say 0.5 in scale, and then it goes bigger while hitting the enemy. So when hitting the enemy, it's at 2 in scale, so twice the size, and then it's going all the way back down to 0.5 at the end of the animation. So the sword gets bigger and then smaller. And now before we can go back and test it, I want to change 2 last little things. First, in my actor location alpha, the maximum alpha I was setting it to was 1, and I think it looks better if we put it to 0.75 now that we have all the spinning and all the other things at the beginning, in the middle right here, because the sword is going to be bigger, it's going to spin and everything. So I think 0.75 looks better in game. And the second thing that I want to change is the static mesh right here. We saw in the game that the sword was thrown upside down, like the blade of the sword was facing the unit that was throwing it, so that's not good. So we're just going to change that. So to do that, I'm just going to change the Y rotation to be minus 90 instead of 90 right here in the top right corner. And now I can compile and go see in game how it looks. So now I have my spell, I can cast my spell sword throw right here, select the tile, cast the spell, and here we go. We now have a sword that spins and hits the right target in the middle of its path. Here we go, just like that. And it works in all direction, even if the tile is higher or lower. We can see that it works perfectly, so good. And it looks pretty nice, I think, so that's good enough for a small spell. But anyway, that's it for this one. Let's go do the next one. So let's start by creating the spell animation. So let's duplicate the sword throw this time because it's going to be pretty similar for the next few ones. So let's go with this one. I'm going to rename it the PP spell anim short range arrow. Now we can go add the entry in the enum, so short range arrow in the enum, and then in the data table. So add a new row for the short range arrow, set the enum value, short range arrow, the animation, the short range arrow, and then for the cast, what do we want? I'm going to set it to a diamond pattern with a range of 3 to 4 and includes the line of sight. Here we go. Now we can save all that and go do the animation. And that's how my spell looks. So here, the first thing I change is the static mesh. I switched from a sword to an arrow because it is an arrow spell. So let's put an arrow instead of a sword. So here it is. I have my SM arrow right here in the top right corner with the materials that I wanted to use. I've also changed the rotation so it's facing the forward axis of the blueprint. I've also renamed the other component, so the anim component, which I named it anim underscore rotation and scale because we're just going to animate the rotation and the scale of the arrow. So that's it for the viewport, and now we can go in the graph to see how it looks right here. And when we are playing the spell animation, we start by doing the same exact thing as the other spell. So we are placing the actor at the right place on the grid right here and facing the right direction. And then we are playing a timeline to set the position, rotation of the mesh and the component and everything. And then we end up calling the event complete spell animation. And as for the timeline, it's pretty similar as the previous one. So we start by lerping between the origin and the target transform to move the actor to the right location. But in this case, I'm just adding a little offset in the z-axis. So we are able to add a little offset in the height of the arrow while it's moving. So it's going up and then going back down. And that's why I'm doing that right here. And the values are coming from the timeline, which we're going to look into in 2 seconds. But yeah, we're setting the actor location right here. And then we are setting the rotation and the scale. So if we go on the right here, we are setting the rotation, which is just the pitch of the arrows. So we can incline the arrow in the right orientation. So it's facing up while it's going up and then facing down while it's going down. And finally, we have the scale right here, which I'm going to use just to make the arrow bigger when it's targeting the enemy. So while moving forward, it's just going to grow bigger, just so it looks a little bit nicer. Okay, so that was for the logic. Now we just have to go check how the curves look. So let's go in there. So the first track is pretty straightforward. We start at the origin index and we are moving towards the target index. So start at 0, end up at 1. But this time I'm not ending up at 1. I'm ending at 1.5, I think, just because I want my target, I want my arrow to go through the enemy completely. So it looks a little bit nicer, I think. Whatever, you can do whatever you want if you don't like it. But in my case, I just want my arrow to go completely through the enemy. Then we have the location Z, which is a little arc. So the arrow is going up and down in the air. And we're combining that with the rotation Y because we want the arrow to face the direction it's moving. So while it's going up, the rotation is going to be facing up. And while it's going down, the rotation is going to be facing down, obviously. And finally, the last one we have is the scale, which I'm just using to scale up the arrow while it's moving towards the enemy. So it's bigger once it hits the enemy. And that's it for this spell. So now we can just go see how it looks in game. So I'm just going to compile and play to see how it looks. I'm going to select my new spell right here. And now if I cast it, we can see that I have an arrow that is moving towards the target tile. It's going a little bit beyond the target tile, but whatever, that's what I wanted. So that's good. And here we go. So I have my spell and this is how it looks. It's pretty nice, I think. And if you want to have different behavior, as usual, you can change the curves. But in my case, I like it and we're going to keep it that way for now. And we have to go do the next spell now. So the next spell is the long range arrow right here. So I started by creating the blueprint for the long range arrow, which is named BP underscore spell anim underscore long range arrow. Then what I did is went into my enum and add my long range arrow spell name right here, and I used it inside the data table. So in the data table, I added myself a new row for the long range arrow, which has the same name as the enum, which I selected right here, long range arrow. And then we have the BP spell name long range arrow that we're using. The range is a diamond. The range min-max are 4 and 6. And I don't want to use the line of sight for this spell. You can use it if you want to, but in my case, I don't want to. So here we go. Now we can save the data table, the enum, and we can go check how the blueprint looks. And you're going to see that this blueprint is pretty similar to the previous one. So first, in the viewport, I didn't change anything. I still have the same static mesh, which is the arrow, the same colors, same orientation, same everything, and same thing for the anim component. So I have the anim underscore rotation scale because we are going to only animate the rotation and the scale of that component. And now we can go in the graph to see how it looks, and it is exactly the same as the previous one. So we start by setting the actor rotation and location based on the origin and target index. Then we are playing a timeline that we then set all the values we need to set, and we end up calling the complete spell animation at the end. All the nodes are the same. I didn't change anything here. I just changed the values from the curves. So that's what changed the most, the curves of the arrow. So we can go inside the timeline to see how the curves look. So for the first curve, the location alpha, I just made sure that the arrow end up on the target tile instead of going through the enemy. I'm going to stop right on top of the enemy's head, so that's good. Then for the location Z, I really wanted that arrow to go all the way higher in the air, so super high in the air. So that's why I increased the values of the location Z. And I've also changed the rotation Y just so it matches with the location Z direction. So when it's going up, it's facing up, and when it's going down, it's facing down, as usual. And I didn't change the scale, I think. So it starts at 1 and then end up at 2. So it goes bigger while it's moving towards the enemy. And that's it for the curve. So now we can go see how it looks in the game. So I'm gonna play, select my spell as usual, and now I can try to cast it. So we can see that the arrow, goes way higher up in the air and then end up directly on top of the head of the enemy. If there was an enemy there, they are not, but whatever, it doesn't matter. So that's how the spell looks right now. You can tweak the curve as usual if you want to. But for now, we're gonna go to the next one. So let's go to the next spell. And the next spell is the Dark Wave. So here it is. I created my blueprint for the spell animation, and now I'm gonna go in my enum to add the Dark Wave element, and then we can go in the data table to add the Dark Wave right here also. I've set the enum value to be Dark Wave, the spell anim to be the Dark Wave, and then for the cast, for the range, I've set a pattern to be a line, which is super simple, doesn't matter, and the min-max range is going to be 0 and 0. So we are casting the spell on ourselves. So the unit is only going to be able to cast that spell on himself. And then it's going to splash on the tiles around him. So I made a cast AoE, a range of squares. So the square around the unit is going to be affected by that spell, and the min-max range is going to be 1 and 1. So only the first tiles around the unit is going to be attacked. So good, now we have an AoE spell to design. So let's go back in the animation, open it, and see how it looks. And here in the viewport, the main first thing that changes is that I now have 3 static meshes instead of 1. So I have static mesh 1, and static mesh 2. All of them are using the same static mesh. They are using SM cylinder with bevel tops that we imported at the beginning, and all of them are also using the same material, so M translucent color. So they don't look the same as the real material because I changed the color in the construction script. We're gonna look at that in 2 seconds. But first, let's take a look at the scale because all of them are the same mesh, but they are a different scale. So I have that one that is a little bit lower than the other ones. I have the middle one, which uses that scale. And finally, I have the bigger one, which is that scale. So now all the 3 components are stacked on top of each other, and I think it's gonna look pretty nice in game, actually, for a simple spell. And now about that, we have to do the animation component, which I just animate the scale for this one. So anim underscore scale, here we go. So this is the new component we're gonna use. But before going to see how the animation is done, we're gonna go quickly in the construction script to see how I've set the colors on my meshes. So you can actually, you can just create material instances if you prefer doing it that way. You can create all material instances of the M translucent color and set all those colors yourself in the assets themselves instead of doing it in the construction script. But I was lazy, so I just did it right here. So I'm doing a set vector parameter values on materials using the parameter name color, which is a parameter that is already in the material, obviously. And I'm setting 3 different shades of purple depending on the mesh. So I have my static mesh using a dark purple, a lighter purple for the static mesh 1, and a darker purple for the static mesh 2. So all my 3 components now have different colors, even though I didn't change any materials. Okay, so now it's time to go take a look at the animation. And actually, for the spell, it's super simple. We first just have to set the location of the spell. The orientation doesn't matter because it's a circle, so it doesn't really have a forward or a backward or left, right? It doesn't have any direction. So we just have to set it at the right location on the grid. Then we play the timeline, which we are using to set the relative scale of the component, the same way we were doing before. But this time there's a little change. We are also setting the opacity of our components. We're gonna take advantage that our components are translucent, so we can fade them out. So that's what we're gonna do at the beginning of the animation. It's going to be bright, and then it's gonna fade out over the course of the animation. And finally, we are simply calling the complete spell animation as usual. Now we can go see how the curve looks. And that's how they look. So first we have the opacity, which is just a float curve that starts at 1 and then end up at 0. So we are fading out over time based on the length of the animation. And then we have the scale. This time we are using a vector curve, which has 3 curves in it. But actually, I don't really need 3 curves. We only need 1, but whatever. I wanted to use 3 curves anyway. So I have my blue curve, which is the Z, which is not moving. So we're not gonna change the scale Z of our component, only the X and Y, which are exactly the same. So that's why we only have 2 curves right here. We have the green curve, which has both the X and Y axis in it because they are exactly on top of each other. And what I'm doing is just I'm scaling up the X and Y. So we are stretching the components on the side. So it's starting at the middle and then stretch on the side to attack all the enemies around itself. So shoo, something like that. So that's why I'm using these curves right here. And that's it for the curve. So now we can go in the game to see how it looks. I'm gonna select my spell right here, Dark Wave. Oops, not the right spell, Dark Wave. And then we can cast it on the grid. So let's say right here. Oh, okay, we can see that the spell attacks all the tiles that are around itself. So and it's fading out as expected. So here we go. So that's the Dark Wave spell. Good. Okay, we can go do the next one. And the next spell is going to be a healing spell. So I have my Spellanium heal right here. And now we're gonna go in the enum, add the heal element. And then in the data table, same thing. We are adding the heal. We are selecting the enum heal, and then the Spellanium heal. And then we have the diamond shape for the range, which I'm gonna use for a range of 0 to 3. So we can heal ourselves and the units that are close. And then I have also enabled the line of sight because we want to see the units that we want to heal. Okay, so now that's done. We can go do the animation. So let's open the blueprint and we can see that it's pretty similar to the Dark Wave. Actually, it's the exact same component for the 3 little cylinder right here. So I have my 3 cylinder without tops right there. I just have different colors, which I've set in the construction script, like the previous one. But I've also added the 3 little extra static mesh right here. So I have 3 little plus signs on the right, left, and middle right here. It's just because we are going to make them rotate around us, and I think it's going to look pretty nice in game. So here are my values for the first plus that is in the air. So I have my location right here on top right. I'm using the same static mesh, so SM plus for all 3 of them, and the same material. So this is the higher one. I have the middle one right here if you want to copy the values. And finally, I have my lower one right there. And that's it for the viewport. Now we can go in the construction script to see how I've set the colors, but I've did the exact same thing. So I'm setting the different shades of green depending on the components, so they have all different colors. And it looks pretty nice just like that. So good, now we can go see the animation. Animation that is pretty much the same as the Dark Wave. We're gonna do the same exact thing. So we're setting the actor location, we are playing a timeline, and then we are setting the relative scale and the opacity of our components, and then we end up completing the spell animation. But what is different is that we are also setting the relative rotation because we want to make the component turn. We want the little plus signs to turn around the target, and I think it's going to look nicer if they do. Otherwise, it's just going to be a little bit too static. So that's why we are adding a relative rotation right here. So now let's take a look at the curve to see how it behaves. So the first curve is the opacity. What I've changed is now that I'm fading in the opacity of the components instead of just starting them completely faded in and then fading them back out. I'm just starting at 0, fading in, and then fade out. It's just a little bit smoother for a healing effect compared to a spell that attacks someone. Then I have my rotation, which I'm just using to spin the components around. So I'm doing a 180 degrees rotation over 0.75 seconds, which is I think it makes sense. It's not too fast, not too slow. I think it's good enough. And then for the scale, I've switched the values completely. I've inverted them. So now instead of squishing the component on the side, stretching it on the side like zoom, we are going to scale it back towards the middle. So it's going to go like zoom and towards the air. So it looks a little bit nicer for healing compared to what we had before that was just attacking the sides like choo, choo, choo. We are going to zoom, scale towards the middle and in the air. So these are my values for my curves. And that's it for this blueprint. So now we can go see how it looks in game. So I'm going to select my spell as usual. And now if I try to cast it, we can see that it looks a little bit like that. Vroom, vroom, vroom. It looks pretty nice with the little plus signs rotating around the target. I think it's good enough. So good, we have our little spell created and we can go do the next one. So the next spell is the Slime Ball spell. So here it is. I have my BP spell anime Slime Ball that I created. I'm going to use that spell for my slimes later on in the game. And now what we're going to do is go back in the enum, add the Slime Ball entry, and same thing for the data table. We are adding the Slime Ball row with the Slime Ball enum and the Slime Ball animation. Now for the range and the cast and everything, I've set the range pattern to be a star and the range min-max to be 3 and 4, just so it's a little bit different than the other ones. I don't need the line of sight, but I'm also setting a cast AoE for that spell. So I have a range pattern of a line for the range AoE, and it's going to target the tile 0 and 1, so just a little plus sign on the grid. That should be good enough for that spell. So now we can go open the blueprint to look at the animation, and the first thing we're going to look at is the viewport. So here I have my 3 little slime balls, so it's 3 spheres that are coming with Unreal by default, and here they are if you want to copy the value. So that's my big sphere, that's my middle sphere, which is a little bit higher than the other ones, and then I have my smaller sphere, and I've also added an anim scale component because we're going to scale these spheres. Now we can go in the construction script to see how I've set the colors because they are all using the M translucent color. So we can change them in the construction script right here, the same way we did for the other one. So I'm just setting 3 different shades of green depending on the mesh. Now we can go check the animation in the event graph, and here it is. So it's a little bit more complex than the 2 previous one we just did, but it's still very simple and it looks a little bit like the first few animations we did. So we start by setting the actor location, playing the timeline. We're setting the actor location again because we want to interpolate between the start and the target tile, and that's what we're doing right here. And then we are setting the opacity because the components are translucent, so why not? It's going to look better if we are fading them in and out as they go. And then we have the anim scale because we want to scale them bigger or smaller depending on the animation. And now we can go inside the timeline to look at the curves. For the location alpha, there's not much to say. I'm just sweeping from the origin to the target tile. Then I have my location Z because I want to throw my spheres in the air and then they are gonna splash on the ground. So that's why I'm going up and down. And that's what I'm doing in the location Z curve. And actually that curve is pretty much linked to the scale curve because while the spheres are going up, I want to scale them like vertically. I want them to stretch vertically. So it looks a little bit nicer and more like fluid. It stretches up, and then once they reach the ground, I want them to splash on the ground. So they're gonna stretch on the side. So it's gonna vroom, vroom. And that's what I wanted to do for that animation. So that's why those two curves are linked together kind of. And then finally, we have the opacity curve, which is just fading in and out at the beginning and at the end of the animation. And that's it for the curve. So now we can go in the level and see how it looks in game. So I'm going to select my spell as usual. And then I can select a tile on the grid. My range is a little bit special because we decided to use a star, which is nice. And then I have my spell that I can cast. It goes whoosh, flush, flush, so flush, flush. So I think it's pretty nice, and we can throw a bunch of slime balls all over the place. Good. Okay, now we can go do the next one. And for the last 2 spells, we're going to do things a little bit differently because we're done with scaling meshes, rotating them, animating them. It's pretty boring. We're going to use different components now, and we're going to do things a little bit more interesting. We're going to show an icon, we're going to show a widget in game, we're going to spawn other blueprints and things like that. So that's what we're gonna do, and it's gonna be a little bit more interesting than just animating static meshes. Which brings us to the first thing we're gonna do for the next spell, and it is to create a new widget blueprint that we're gonna use inside that spell. So let's go in the components and create ourselves a new widget blueprint, which I'm gonna name W_image, which is just going to contain one image. So let's open it to add that image actually. So let's go in there. In the palette, we can select an image. Actually, I'm just going to delete the canvas panel. We're not gonna need it, and just drop the image in the viewport. I'm just going to rename it because we're gonna use the variable. So image underscore component, I guess. I don't know, doesn't really matter. And now we just have to make sure that it is a variable in the top right corner. Here it is. So now we can compile and close the W image because we're done with it. And now we can finally create the new spell. So here it is. I have my new spell. So I named it run chicken run, and it is going to be a buff, a stat increase for my chickens. The chickens are going to be able to give themselves more movement points. We can't do that right now because the logic is not there, but we are going to do the animation today, and later on we're gonna do that mechanic. But for now, we just want to be able to spawn an image on top of the head of the chicken. Let's say an icon, which is the icon that we imported in our assets right here, the little chicken running. So that's what we're gonna use. So first, we create the spell the same way as the other one. So I have my run chicken run spell right here. I also added it inside the enum. So run chicken run in the enum and in the data table. So run chicken run. It's using the same enum value, the same spell right here, though. So BP spell enum run chicken run. And then for the range pattern, I'm using a line, and it is only casting on itself. So range min max is going to be 0 and 0. So the chicken is only going to be able to target himself with that spell. So now that's good. We can go do the spell itself. So let's open VPNM run chicken run, and we just created a widget that we want to use right now. So let's add it as a component to the blueprint. So in add the component, we can search for a widget component right here, and then we can add our image to it. And on that component, we have a few things to change right here on the right. First, we want it to be a screen space widget because the icon, we want it to be in screen space. So screen space. And then the widget class, well, we want to use a new widget class we created. So W underscore image, which is just right here, W underscore image. And that's it. Now we can go in the graph to do the logic of the animation. And we're going to start it the same way we are doing for all the other animation. And it is to set the actor location using the target index, just like that. And then once that's done, since we want to use the widget component that we added to the blueprint, well, it would be also nice to have access to the widget that is inside the widget component because we only have the widget component now. We don't have the widget that is inside it. So that's how we are accessing it. We are getting the user widget object from the widget component, then casting it to the widget class we used, so W image, and we are setting it inside a variable, which is just right here. And then once we have that variable, we can use it to set the image that is going to be visible on the screen. And we're doing that by using a set brush from texture. So we are setting the brush of the image component inside the widget. So the white square that we set in the widget blueprint, now we are going to show something different on it, something different than a white square, which is a good idea, I think. So now right here, the texture I'm using is the icon run chicken run, which is the icon we imported at the beginning of the video, obviously. And then it continues the same way as all the other spells. We are doing a timeline for the animation right here. And once the timeline is finished, we are calling the event complete spell animation. And inside the timeline, there's three things I want to change. First, the location Z. I want my widget to move up in the air while the animation is playing. Otherwise, it's too static. It's not nice. So we want to make it move a little bit. Then we have the draw size, which is pretty much the equivalent of the scale. So that's how we're doing it. We're just simply setting the draw size of the widget component using the draw size provided by the timeline. So we are going to animate the scale, make it bigger, smaller, whatever, as long as it is moving a little bit. So it's going to be more interesting. And finally, the last thing we have to change is the opacity because we don't want the image to just pop in and out in place. It's not nice. So we want to make it fade in, fade out at the beginning and at the end of the animation. And that's what we're doing by using a set render opacity on our image. So that's how we are setting the opacity of it. Now we can go inside the timeline to see how the curves look. And here they are. It's pretty simple. For the location Z, we are just making it move up in the air over time. The draw size is just going bigger over time. And finally, the opacity is fading in and fading out. And that's it. So now we can compile and save this blueprint and go see how it looks in the game. So now I'm gonna select my spell, run chicken run, and try to cast it. And here it is. This is how the spell looks. It goes up, it fades in and fade out. Here we go. Now I have a bunch of chicken. Woo! Okay, so that was another way we can use the blueprints to do the spell animation. We don't just have to scale up and down static meshes. We can do anything we want. So that's why blueprints are nice. Okay, good. Now we can stop and go do the last spell of the video. And that last spell is going to be pretty similar to the spell that was spawning red cubes on the grid. We're gonna spawn other blueprints that are moving on the grid, but we're gonna make it a little bit different, so that's why we are gonna do that today. So I'm gonna go in my components first, and I will start by duplicating BP animated shape. I will rename it BP animated wind gust, because this is the name of our spell. Now we can just open the blueprint just to modify it a little bit. And because I'd like the blueprint to compile, the first thing I'm going to change is the callback. So we can select the callback on the left and change the input variable type to be wind gust, because otherwise it doesn't work. Now we can compile and it should fix the issue. Then I'm going to go in the viewport to change the static mesh, because right now it's not set to anything. So I've changed the static mesh, so it is now using SM wind gust that we imported at the beginning of the video. And then I've also changed the material, so both materials are now using M translucent colors like all the other spells we did today. And then on the left, I've also renamed the component, so it makes a bit more sense. So now it's named Animated Wind Gust. Okay, good. Now it'd be nice to change the color of the wind gust, because right now it's a bit orange brown. It's not pretty. So let's go in the construction script to change the color. And that's how I did it, and it's a bit different than all the other spells that we did today, because the static mesh that we're using has two materials elements on it. So it has two materials, and we don't want both of them to have the same colors, so we can't really just use the set color parameter on materials function. We have to first create a material instance dynamic right here, and then we can call the set vector parameter value. The material instance dynamic is set to a specific element index. So right here I have the element 0 and I have the element 1. So I have my first material and my second material. So that's why we have to split them into two different materials. So we have two of them right here. And then individually we can set the color on each of them. So we have one color for the first material, one color for the second material. That's why the code is a little bit similar, but it's different. The only thing that changes is the element index right here and right there. And then for the colors, I'm using two shades of green, two different shades of green. So I have a darker green and a lighter green right here. And I've also added a bit of range, a random in both those colors, because we're going to spawn multiple actors at the same time. This is going to be an AoE spell, so it's going to spawn multiple of them. And it will be nicer if there is a little bit of variation in the colors. And now if I go back in the viewport to see how it looks, I can compile the blueprint and see that now the colors changes every time I compile, because it's random a little bit. And now we just have to go modify the graph a little bit. So let's go in there, and the first thing I'm going to do is actually deleting these three first functions right here. So the set static mesh, set material, and set vector parameter value on materials, because this is just for the static mesh and the colors, and everything is already handled in the viewport and in the construction script. So we don't need those. I'm just going to delete them. And I'm also going to delete the mesh on the left right here, the material, and the colors, because we don't need it anymore. Good. So now we can just connect it back at the play rate just like that, and bring everything a little bit closer to the begin play, just like this. So now we are setting the play rate, that's good, and we are playing the timeline as before. That's great. Now the lerp is pretty good, that's great, but we're not gonna use this right here. We're not gonna use the height offset nor the +100 that we have right here. So I'm just going to disconnect that, and I'm actually just going to recombine the pin just so it's a little bit cleaner, just like that. Now it's a little bit better. But now we end up with an extra track in the animation timeline right here, the height offset, that we're not gonna use. So we can either delete it or we can reuse it for something else. And that's what I'm gonna do. I'm gonna use it for the opacity of our mesh right there, because now we are using a translucent mesh, so we can change the opacity, and that's what we're gonna do. So we can just reconnect it like so, and then we can open the timeline to tweak the curves a little bit. And I'm not actually going to change much, because the transform alpha is good as it is. I don't want to change that. I just want to rename the height offset first, so it's named opacity now, because that's what we are using it for. And then what I'm going to do is just change the maximum value of the curve. Right now it's 1000 whatever. I'm just going to make it 1 instead, because it makes way more sense. I'm just going to now rearrange my curves. So I'm just going to select them and make them auto again, so it's flatter. And I'm just going to zoom them. Okay, here we go. That's how it looks. And I think it makes sense. It's pretty good. I'm just going to make it maybe visible a little bit sooner or something like that. I think that's good enough. So now it's going to be visible at the beginning and then fade out. And that's what we want. Good. Now we can save this blueprint. We're done with this component. And now we just have to go do the spell. So I'm going to go here and create it. So as usual, I created my spell anim right here. So BP spell anim wind gust. And now I'm gonna go in my enum to add the entry wind gust at the end right here. And then we're gonna use those inside the data table. So in the data table, I have my wind gust row right here at the end using wind gust and the spell anim wind gust. For the range pattern, I'm using a square this time. And the min-max range is 3 and 3. I'm using the line of sight for the cast, and I'm also using the line of sight for the AoE cast. I think it will be interesting to have a spell with the line of sight for the AoE cast. And for the AoE cast, I'm using the star pattern with a range of 0 and 2. Here we go. So now we can save all that and go back in our spell. And now let's open the BP spell anim blueprint to do the animation logic. So here is the beginning of the animation. So play spell animation. And we're gonna do the exact same thing we did for when we were spawning the red cubes on the grid. We are going to loop through all the attacked indexes and spawn a red cube for all of them. Actually, not a wind cube in this time, a wind gust, but it's the same logic. So we're looping through all the attack indexes, but this time we're going to make sure to ignore the target index, because the thing that I want to do is to spawn all the wind gusts from the middle, from the target index, and then they are going to move outwards to the attacked indexes. So I don't want to have one wind gust that stays in the middle because it's going to have the same transform at the beginning and at the end, whatever. And so that's why we are ignoring the target index. So there's no wind gust that is going to spawn and stay in the middle. It's going to be ugly if it is there. So that's why I'm removing it. Now for all the indexes, well, we are simply spawning the actor wind gust, the animated wind gust that we just created. So we are spawning it. And then for all the wind gusts that we spawn, we have to set the origin transform and the target transform. So for both of those, we're going to use a make transform, which we're going to populate by first starting with the location. So for the location, it's simple. We're going to start in the middle, so from the target index, and then we're going to move outwards to all the attacked indexes. So everything's going to start in the middle and move outwards. That's why we are doing it like that. So start location, it's the target, and the target location is going to be the attacked index. And then we can do the same thing for the rotation, because while the actors are moving outwards, it will be also nice that they are facing the direction they are moving into. So if the wind gust is going to go that way, well, we are going to move in that direction, look in that direction, and move in that direction. Same thing if it was the other direction. So that's why I'm using a find lookout rotation right here. And the last thing we have to change is the scale right here. It's 111 everywhere, but I think it will look a little bit nicer if it starts small and end up a little bit bigger. So I'm going to start at 0.5 in scale and end up at 1.2 in scale. So it's going to grow over time as the spell plays. And finally, we have the play rate. So we can add a little bit of a variation in the play rate speed. So I can just make a random floating range between 0.8 and 1.5. So all the wind gusts are not going to play at the same speed. They are just going to have a little bit of variation in them, and I think it's going to look nicer. Well, last thing we have to do before ending the video and finishing this spell, it is to destroy the spell blueprint, because I'm never calling the spell completed right now, so that's what we are going to do. And we're going to do that by hooking ourselves to the end of the animated wind gust animation. And we're going to do that by first doing a do once, because we only want to bind ourselves to the first wind gust we spawn. The other ones don't really matter. We just want to bind ourselves to the first one. And then we simply attach ourselves to the callback. So bind event to unshape animation completed, calling ourselves a new event we just created. It doesn't really matter as long as it is used to call the event complete spell animation. And that's it. Now we can compile and save everything, and we should go see in game if everything works as expected. And that's how it looks. Pretty nice, I think. Yeah, it seems to work. Everything starts from the middle and attack all the other tiles that are outside of the range. So that's pretty nice. Good. And I think that's gonna be it for today, actually, because we did a bunch of spells already, and we have done a lot of things, and it took a long time to do all that. But yeah, but now it's nice. We have all the spells we need to finish the series for sure. And now we'll be able to assign all those spells to all of our units, and they are going to be able to attack each other. And that should be the next step, I think. I don't know. I'll see how I feel and if I think about something else first. But yeah, anyway, for today, I think that's gonna be it. And I'm gonna see you in the next one. So bye bye.